Plots? What?
Your QQ plots. Did you guys do them, or how did you get a QQ plot? Did you?
The QQ plot, you had to go back to like the first Excel file
that we had.
Quantitative, descriptive.
And then
put in.
And then you put in the whatever it's called, the residuals.
Yeah.
And then you have to organize it from smallest to highest.
Okay, and that was my problem because I kept putting in my residuals and it was like freaking out. I needed to put them in order. Okay.
Yeah, with the QQ plot, you always have to remember you have to do it from smallest to largest because if you don't do it that way, then it'll never be aligned.
It's gonna be like a scatter plot.
Okay, yeah. That was my problem then, and I just keep thinking, what is going on? Okay, well, I don't have any more questions other than that.
I had a question on the homework. It was the first question on the homework. What are the three differences between these two equations?
It didn't even give it on the answer sheet. It said see the wiki, which I don't know.
Well, the wiki.
Well, question 2 was refer to the wiki. But question 1, I don't know what the three, I mean, it sounds like there's 3 significant differences. I could probably like make a guess, but it sounds like we could see that question again and I don't know the answer.
So the one equation is like the y hat with the little b's, and then the other one is just the plain y with the capital B's.
With the expected value?
Yeah. So the one's estimated, the one is the actual.
I never noticed little b's and big B's.
Yeah, and then the one has the error term with it.
Right.
With the big B's. Those were
what's the difference?
That I saw.
What's the difference between the big B and the little b?
Let me go back into it. So the big B's is the what's it called?
Beta.
Yeah, I just can't think of it.
Unknown coefficient.
So
the big B's, I sound really weird saying big B's. Anyway, they stand for unknown coefficients.
Yeah, so I think that because that's your estimated equation. So those are like the unknowns, like the estimated B's. Whereas the other ones are the am I doing that right? It's been a while since I
have it backwards.
Yeah.
The estimated has the little b's.
Yeah.
It says
I'm going back to lesson 22 because it's comparing the lesson 22 to lesson 23.
Charlotte, just 1 second. I'm sorry. Go upstairs. I'm not going to ask you again. Go upstairs and see Addie. Period. And stay up there. I'm sorry. That's the way it goes. She's not feeling well. All right.
So the estimated isn't the estimated. The estimated is the beta.
That's what my understanding was.
Yeah, that's what I thought. Okay.
Because it says these two coefficients are estimates of the unknown regression coefficients in the true coefficient. So we will use the Greek letter B or B.
Where are you reading this?
That's in lesson 23.
Oh.
It's the very first paragraph in 20.
Okay. I didn't even lowercase and uppercase. Okay, so the Greek letter B to denote the true unknown coefficients. And
then you add the epsilon, which is the error term, to adjust it so that's on the line.
So the little b's, they represent the y-intercept and slope.
Yeah.
Don't the big B's also?
They do, but the one is the let me go back to it.
When this is
the one is the true linear equation, and then the other one's the estimated. So I feel like it's going back. It's kind of like the sample stuff, you know, when you have like the parameter and then the sample.
Right. Kind of like the mean of the mean stuff.
So we use little b to represent the y-intercept and slope respectively. These two coefficients are estimates of the unknown regression coefficients.
So I feel like this other equation with the betas and the epsilon, that's trying to get to the other equation. That's trying to get as close as we can to the other equation, I feel like. Because the other equation is the actual true equation.
Yes. Cat, the dog, the kid, I'm there to play. Okay, all right. Okay, that's good. That gives me something to...
Do you know what? I think it's actually opposite. Sorry, now that I'm reading this a little better. Okay, so what it says is, in the estimated regression equation, we use little b to represent the y-intercept, slope, respectively, and slope, respectively. These two coefficients are estimates of the unknown regression coefficients in the true equation. We will use the Greek letter B to denote these true unknown coefficients. So it's actually flipped. So the little one, the estimates, and the big B is the true unknown coefficient.
Okay, it's like the population and the parameter.
Yes.
And
yeah, it's the X bar.
Okay, and the little b estimates of the unknown regression coefficients. Yeah, it's just so foreign language to me.
There we go. Yeah, so the summary box is actually way easier to understand.
Yeah.
Than that. Just go to the bottom.
Yeah.
So the unknown true linear line. Yeah. So basically, this is the population, and then the little b is the sample. That's how, in my mind, anyway.
The little b is the sample, and the big B is the population.
That's how I'm interpreting this.
Okay, I understand that. I understand what it's there. And it's, the little b is kind of like the sample.
Conceptual.
No, yes, conceptual, but abstract to me. I don't understand what it's talking about. So it's a lot of just like rote, like
yeah, same for me too.
Yeah,
so I'm
that's why I was like, I'm not going to comment because I don't want to mess up what I have figured out. I'm like, I'm just going to.
It doesn't make a lot of sense of how this is meaningful in any way.
Yeah, so I figure I'll just write out a lot of definitions and write out a lot of stuff on that one page we get for the test and roll from there. All right. Okay, so then I had one other question on the homework. I did this homework. I got up at like 5 this morning to do it because then I went back to bed. It didn't take me as long as I thought it would because I didn't get it done yesterday. So there was a question. It was, 13A. When I looked at it, it looked like a hot dog shape to me in my graph. But if it's all horizontal, does that mean, does it have to be a diagonal? Because in the graph I
had the exact same thing happen. And so that's why that was the conclusion I came to. So that if the line is horizontal without a slant, then it's not a linear. That's the conclusion when I came from the answer.
Okay. Because, yeah, I looked at them like, well, it looks like a hot dog, but they're all straight.
Yeah, it was just a straight line.
So I can put a straight line through that really easily. But it wasn't a sloped line. So, okay.
I don't know if that's true, though, Heather. That's what I deducted from that.
I don't know either. Because if that particular question came up on a test, I would think it was linear. Because I'm like, you draw a straight line through that. It doesn't look random to me. So...
Right. I think what it's saying, though, if it's horizontal, is that the relationship is not linear because it's not showing that if it goes up a certain, so like as the slope goes up, then the points follow that. You know, the response variable is supposed to show that if the line starts to go up, then it does too. I don't know if that makes sense. So if it's horizontal, it's not showing that relationship.
That makes sense. That makes sense. I see what you're saying with that. All right. I think that's all the questions I had. Anyone else have any questions? Okay.
No.
Are we ready to start the quiz?
Yeah, let's do it.
So can I just say that it really bugged me how much of this, well, let me ask you this one more question. I had a lot of stuff in the lesson that didn't match up to their answers, I think because they're using SPSS. But specifically,
yeah, the lesson really bugged me today because it was all SPSS, and then they were like, "Oh, and here's how you do it in Excel." Like
all the answers didn't match up. All of them were a little bit off. And then the thing that really bothered me is the N number on page 8 of the actual lesson. I had N of 35 and they had N of 30. And I checked
they kept showing this form, like the little tables with the degrees of freedom and stuff like that. We don't have that on our form in Excel.
The thing, that totally threw me, and it took me forever to figure out that I don't need to try it.
Yeah, the ANOVA table?
Yeah.
And the degrees of freedom. This is really, since we're live, this is really a subpar lesson and needs to be modified. This is.
Well, I'm going to put all of this because we have the course review coming up this week. And I actually got an email from BYU Idaho that said they wanted me to review my 2 courses. Like they sample out certain students to like do big reviews, and now I'm it's all going down.
It's really confusing. We're trying to learn new stuff, and then it's talking about how you find the degrees of freedom, and we don't have that on Excel at all.
No. But none of the stuff matches. None of our if you want us to use SPSS, fine, make it part of the course, and teach us how to use it. Don't tell us the only program we need is Excel, and then use this other program constantly that we have no knowledge or access to.
Yes,
But no, this lesson really irritated me for that exact reason.
Oh, it's frustrating. Yeah.
Okay, especially when it's the final one, and you're like, okay, one more to go, one more to pound in there, and then you're like, what? Degrees of freedom? Am I looking at the wrong thing? You get them thrown off and confused and think.
Yeah.
Like, or is this just a flaw in the what we have given to us? And it's hard enough for me to understand this without throwing out stuff that doesn't match up. Because anyway, all right, I'm ready to start the quiz if you guys are. I'm over my
got it up.
Where did I have it? I had it up. Where did it go?
I just have to get my quantitative statistics up here.
Had all this up before we started. Where did it go?
Alrighty then. Okay.
It's supposed to be B1 equals 0 and B1 does not equal 0, correct?
That's what I have.
That's what we did in the lesson. And a residual is the difference between
the value of y
and the value predicted by the regression.
Yes.
A second. So the first one is C, right?
Yes.
And the second one,
C.
The difference between the observed value of y and the value predicted by the regression line. So abstract. I don't even know what it's talking about, honestly.
I know.
I just got to fake it one more week.
A plot of residuals supports using linear regression when it is
normally distributed.
when you see the megaphone.
No.
No, it's like they do not.
No.
I'd have to go back and look. Hang on.
I think it's A.
Yeah, because
I
I
think
think it's just so random scatter.
The residuals evenly distributed.
No, talking about the QQ, isn't it, on this? A plot of residuals supports.
Okay, the plot of residuals supports a linear regression according to this chart when there's no pattern in the residuals.
Right.
So it's not the last one, and it's not D, it's not C. So it's either A or B.
Well, in B, we have some that are negative, some that are positive. It doesn't.
So it's gonna be A.
So it's A.
They've never distinguished that they had to be positive.
Let's
Because
put
you can
A.
have them all be negative. So
Sounds good to me.
The residual plot. Yeah, that's a weird thing. They're normally distributed when they're random.
Yeah. Well, I was looking for that.
if they cover the whole thing in randomly scattered
And they're
places, then it's all.
Which is the opposite of every normal distribution we've been talking about. I think it's A. Does everyone think it's A?
Yeah.
Yeah. This is A.
Okay, and so this next one, we're doing that math self-efficacy.
Yeah.
With it last time where we copied them into the wrong columns. If I remember correctly, the score is the response value.
Well, it tells you right there. It says use the confidence variable as the explanatory variable.
Okay. I just was trying to remember it from last time.
The confidence is X and the score is Y.
Yeah. Because we had it backwards.
Mm-hmm.
So you remember that one question that we all missed and got the same answer?
Yeah.
They've looked into that and the key is wrong.
Ha ha ha.
Well, we figured it out anyway. Isn't that the one that we figured out was flipped? And we had our data flipped, or was that just something different?
No, this is something different. This is when different.
So it says compute the residuals. Are we supposed to do a residual plot now? Or residual?
Probably, but I'm not there. I'm still. Are you guys? Have you guys all got your data in already?
Yeah.
Okay. Residuals, then what?
Put it into a plot.
No, wait.
Plot.
The residuals form a linear pattern, right?
Hold on.
Well, it's showing that the residuals are between about -40 and 25.
The score
And
is
25, yeah, they are.
So I don't know if C or B or C are correct. No, I think it's A.
I think it's A because they don't form a linear pattern. I mean,
okay, now I've got the data in now. Where's
now we gotta do a stupid QQ plot.
All right, now we gotta get the
Wait a second.
water turtle.
Compute the residuals. The residuals form a linear pattern. Did you guys already put it into the? Oh wait, we have to insert the. Hang on a sec. You guys already did the insert the scatter plot for the residuals.
Yeah.
Yeah.
These are so fast. All right. Insert.
I can't move the residuals that to the QQ plot. Like it's because it's a.
It won't do it.
Because it's a formula.
Oh, but do you paste special? Let's see. Hang on.
The residuals are fairly normal.
So how did you paste them in?
You just
Because when I do it, it says it's a
case, and you just
formula.
paste the numbers, not the equation.
Oh, okay. Okay, that must not be what I'm doing. Hold on. Copy. There we go. All right, then we have to go up and we have to go to.
Mine still didn't work. I'm going to trust you, though.
Smallest to largest. Okay, they're fairly linear. Actually, extremely linear.
They're very linear. They follow that line pretty good.
I know. It looks like a little line of kindergartners.
Yep.
They're all like mostly there and just a little wobble.
Wow, my computer is really acting up. Come on.
Okay, so wait a minute. The QQ plot, they're fairly normal. Okay.
6 is the residuals form a linear pattern.
Yeah, no, the negative 40 to 25.
Wait, how do you figure that?
You look at the chart and they go down to negative 25 and the high, or down to negative 40 and the highest they go up to is 25.
So you have to make that separate scatter plot with the residuals.
Oh, that's why mine go like that. Okay, I see, because I didn't. Okay.
Okay, so we created a scatter plot of the data that was over here. Okay, so where's my scatter plot? I gotta find it. Oh, mine was like way hiding.
40 to 25.
Oh, I hate question 8. Ugh.
Yeah, okay, so we look at the scatter plot we made, residuals, and the QQ plot, which are the 5 assumptions about linear regression satisfied by this data. The residuals are normally distributed.
Okay. Okay.
It's all of them, isn't it?
The observations are independent? That doesn't make sense.
You can pick all of them.
There's a check all that apply, so.
The observations are the X. It's, if you look at the, because it's saying, so like the 5 checkpoints was that there's a linear relationship between X and Y, so that means the scatter plot has the hot dog shape. The error term is normally distributed, so the QQ plot of residuals are close to the line. The variance of the error terms is constant for all values of X, so there's no megaphone shape in the residual plot. The X's are fixed and measured without error. The X's should be measured accurately and precisely. And the observations are dependent, which means knowing one of the values of Y tells you nothing about the others.
Okay.
And
wait,
how would we know if knowing the value of one Y tells us about the other?
We
so
don't know
why is the dependent variable?
But we can't check if the observations are independent. We can't check that. It says requirement 3 and 4, X's are known constants. It says in like the little box at page 5, it says it cannot be checked directly.
Yeah.
How to
but
check?
It says directly. So is what you hope to see is that the indirect way to check it?
And observations are independent. It cannot be checked. Knowing the value of one of the Y's tells you nothing about the other points. How do we know that? Because we can't check that.
Well, it just says you can't check it directly. So are there indirect ways you can check it?
I feel like there's just certain things that we assume, like with the data, we assume that they are measured without error. Right?
Yeah. X's should be measured accurately, yeah, and precisely. But yeah, I think that's an assumption we can trust. I say we mark all of them.
Okay.
Is that what you concluded, Laura?
just assuming.
When you went through that list, it was like checking off everything.
Yeah, because I was just reading the 5 things and then the how you check it. Because I just feel like knowing one of the values of y doesn't mean that you know anything about the other values of y, because you need the x to know what the y's are going to be. Right?
In the slope, is that what you mean?
No. As far as like x and y, x is the independent variable, y is the dependent variable.
Oh, yeah. Yep.
Yes. So we're gonna mark all 5.
I think it's all 5.
Okay, so the slope
is 12.695.
Oh, yep, got that.
Yep, that's what I got too.
Okay, lower bound.
10.674.
Yep. Let me type. Come on, computer. And then 14.715.
Yep.
So did you guys
did we put 7 as C or B? The residuals are fairly normal.
Yeah.
Yes.
Okay, good. Okay.
So in number 9, it's talking about little b, and then in number 10, it's talking about big B. So
I know, I saw that, but I don't have any difference here.
Is there a way to look at little b and big B on the answers up here?
Not in this Excel sheet. There's no way to look at beta.
No, that's why I'm thinking I think they're the same in this circumstance, and they're doing it to throw us off.
Maybe.
I think it's probably just a mistake. Do you know there was a mistake in the answers on the homework?
No, I mean, I think it's true, because when we go back and look at like the mean of the population and then the mean of the samples, they were always the same. So I think the same type of situation here. So.
Okay, so 12 is reject the null because the p-value is less than the level of significance.
Yeah.
What was the p-value? Oh.
3.12 exponent negative 24.
But it's also we reject. Yeah. So that's 0.
And that test value, that t, is very close to what we have, but it's not exactly. But you don't reject the null because of the t. You reject the null because of the p.
Mm-hmm.
Right.
So you guys got C, right?
Yeah.
Yep.
Okay.
Yeah.
It means that we have sufficient evidence to conclude that the slope of the regression line is not 0.
Yeah, so D?
Yeah.
Yes, D.
Because it's the null hypothesis is equal to 0. We're rejecting the null, so it's not equal to 0.
Do you know on the prep, question 4 on the prep, they have the hypothesis test as the HO is B1 equals 0, and the alternative is B2.
Yeah, that's
I think that's a typo.
typo.
Yeah, that's a typo.
It did throw me off for a second, though. I'm like, what's the B2? What does that mean?
It should be, they've been using this for like 4 or 5 years or something. These typos should be fixed.
Yeah.
All right, for this data, which is the dependent variable? The dependent variable is body length.
Yes.
Okay, and we're using the Eshtrwan. How do I say that? Eshtrwan.
C.
clear my form here.
Sorry if you guys can hear Mickey Mouse Clubhouse.
You're fine. I don't hear it.
Determine the margin of error.
So what did we get for, what's the question?
Margin of error for the 95% confidence interval. So that's just the second one minus the first one divided by 2, right?
So you have 8.1
minus 7.218 divided by 2, right?
Yeah. Yep.
So I got 0.442.
Yep. No, it's 0.443.
What?
I really
That's
have
not what I
0.442435492.
Oh, maybe I messed up. Mine says 0.4425.
what numbers are we using, guys? Because I want to make sure we have the right numbers because we're all getting this different.
The confidence interval.
Yeah, but
So
are you using slope? So you're using.
Yeah, you're doing the slope confidence interval. So what I'm doing it in Excel. So I'm doing the equals, and then I'm clicking on the one cell subtracted by the.
I'm just trying to make sure I have the same values as you guys.
Yeah, it's 8.103 for the large, and then for the lower end, it's 7.218.
I needed to find out. Well, I subtracted 8.103 minus 7.20. That would be why. Hold on.
Yeah, I keep getting mine is 0.4425.
I think it's because mine isn't rounded.
Wait, I'm not getting a minus. How are you getting a minus?
I'm not getting a minus.
Yeah, we're not getting
0.4425. Allison.
I wonder if they've made allowance for both answers.
Well,
yeah, because you guys are just doing it with those 3 decimals, right? And then doing the division.
Yes.
Yeah. So with mine, I think because I'm selecting the Excel cells, they're not rounded.
Yep.
So that's why I'm getting the answer I'm getting, 0.442435.
so it would round to 0.443, right?
If you're doing it with a calculator, 0.443.
I'm gonna put it in as 0.443. Hopefully they give you both. But which is the
lower bound.
And so that would be A for 18, right?
Yep.
I'm still the lower and upper bounds.
Had 0.4425.
I did too.
Okay.
Yeah. All right. Based on your lower bound and upper bound from master problem, what can you say about B1? It's A, yeah. Did you get Laura? Did you get A for 18?
Yep.
Kind of seems like the only logical one.
Mm-hmm.
Like whenever they say chance, they've like
chance is not the right answer, but there's insufficient evidence to reject the null, even though the p-value is. Are you sure? Look at the p-value. What'd you guys get for a p-value?
Yeah, but the question itself says based on the lower bound and upper bound from the last 2 problems, what can you say about beta?
It's talking about confidence interval.
1.
Huh?
We missed 1.
Oh, you
Yeah.
put it in.
Which one did we miss?
I'm looking. 8.
8.
They're not all. You don't check all of them.
Aha.
Okay,
Well,
so 18 is there's insufficient evidence to reject the null, or it's A, 95% confident.
90%. 90. It's A.
A. Okay.
I think talking about a conclusion like that, like what can you say about it? I think it's easy. I mean, I think that it's mostly talking about confidence interval.
Yeah, they're just throwing that in there to throw you off.
That's lame. At this point, I think that there's only 3 of them. I think that it's the linear relationship between X and Y, yes.
The first 3? Do you want to just do the first 3?
That's
the
probably.
residuals but you can't, I mean, if you go with, you can't check if the X's are measured without error, right? And you can't check if the observations are independent.
It makes sense that it would just be the first 3. If this is wrong, then the bottom 2.
I'll submit it and we'll see, okay? Because let me just make sure I got all the rest right, the same as what you guys got. Let me just go over them real quick because I'm a little half a bubble off today.
Okay.
That's kids, and I feel like I'm coming down with it, so.
Number 1, true.
Oh, thank you. Okay, thank you. Number 1, okay, I'm going to switch it. I put false. I was confused. Just one sec. I think I could just glance at them and make sure I put what you guys put. 7, we put B, right? Then 12.695, 10.674, 14. It's 1114.715.
Let me get there.
14.7.
For which one?
7.715.
14.715. 15 is D. 14 is body length. 15 is 0.443. Is that what you put in, Lorena? 0.443?
Instead of which one?
With the calculator way, right? The margin of error, 0.443.
Yes, 4.
And then was 7.218. Yes, and yes. And then we put A for 18. All right, so I'll submit this and see if just the first 3 are right. %.
Okay,
there you go. All right. Let me get out and go back in if someone can just read the stuff to me.
Okay.
So I don't have to print it off.
Yep, whenever you're ready.
To get back to it. Okay. All right. 1 was C.
You mean
or 2, 3, whatever
Yeah,
it is. 4.
4 was C.
Okay. History A.
5 is A. Yep. 6 is A.
Oh, 6 is A. Oh, that's right.
Yeah.
Okay, I remember now.
7 is B.
Okay.
The 8 is the top 3 only.
Okay.
9 is 12.695. 10.
10.674.
Yep. 14. Now you got 9 is 12.695, right? And then 10 is 10.674. And then 11 is 14.715. And then 12 is C, reject the null. And then 13 is D. And then 14,
D is in dog.
D is in dog, 13, last one.
Every so often it breaks up and then I can't understand. And the body length is the dependent variable.
And 15 is 0.443. 16 is 7.218.
Okay.
17 is 8.103.
Yep.
And then 18 is
And
A. It's on